My name is Burleigh Prahl, and my mentor was Prahl, and I just want to thank him a lot for helping me learn how to weld and do all the stuff he did. Before we go inside, I want to demonstrate to you guys my floating arm trebuchet, and I built this with my mentor, and it is kind of weird how it works. Basically what happens is the 70 pounds of barbells right here will be up here, and this arm will be kind of down like that, and when I release the weights, the 70 pounds of barbell will thrust the arm that way, sort of, when it goes. It's kind of weird how it works, but it'll thrust the arm and it'll throw the onion. Oh. So, right now, I'm going to lift the weights up. It's a lot easier to pull that cable out with gloves. Connect the safety. This right here is the safety. Now, I hope I can do this in gloves. And this is the hairpin trigger. This is what, once the safety's off and the winch is off, I just pull this rope and it should fire. So what we did here was we just drilled 2 holes in the arm and put that in. And welded it. This is the sack, and it is made of lacrosse goalie net material. Now, when we tried originally, it broke, so we had to kind of step it up. I think I need a bigger projectile than what I have here. Hopefully. So, it's pretty simple how it works. The one problem is it's kind of hard to do alone. It's easier when someone's holding that, but in fact, Dylan is too. Now the onion is in. That should work, I hope. Now, it's always a good idea to have the winch off, because the arm comes over here, you don't want the whole thing. Alright,
so Burleigh, tell us where to look.
Alright, so it's going to go somewhere over there, I hope, if it works, which it should. But yeah, now would be a good time to kind of step back.
Yeah, maybe this will clean up. Everyone should probably be up on this direction.
It doesn't really make a difference, Mom.
It does. So, I don't think.
It's all good, okay? You don't have to worry this much about it.
Alright, just no one wants to be directly behind it.
Yeah, behind you or in front of you are the worst places.
Okay.
Alright, I'm taking the safety off, so now it's kind of... Alright, here we go. Now see if you can watch the way the thing works. It's kind of weird. Alright. 3, 2...
Wait.
What?
Everybody's ready. I got it.
You guys ready?
No, right there. Okay, go ahead.
Alright. 3, 2, 1.
you, Burleigh. And so now we are going back inside. Go and find your...
My dad helped a lot when we built that because it's very hard to get all that stuff squared up. It's so super precise when you're doing that. All right, so one thing...
Don't you like Burleigh's outfit?
One thing I did not put full weight on because if you had full weight, it would go too far into the trees and you wouldn't be able to see the onion as much as you did. Alright, so welding is a sculptural process or fabrication that joins two materials, usually metal or thermoplastics, which is like a plastic that can be melted and welded together by causing cullants. This is often done by melting the workpieces and adding a filler metal, or the rod, to form a pool of molten material, which is the weld pool, and that cools to become a strong joint, and the strong joint is the weld bead. Now, the best demonstration of the weld pool is oxyacetylene welding, and oxyacetylene welding is very, very simple. Basically, it starts out with two gases, oxygen and acetylene, and then that goes through regulators and two hoses to a torch. This here is an oxyacetylene welding torch, and out this is the acetylene valve, and then there's a red hose and for oxygen is great. And this has a welding tip. There's also a cutting torch tip. So that's the torch. Out of the tip right here comes a 5600-degree flame, which is the correct flame is the neutral flame. And then what you do is with your torch, if this is your workpiece, you heat it up and you begin to make a little pool about half the size of a pen. And once you've got that pool, you begin to add rod. And this is a real oxyacetylene welding rod. So you just sort of do that, and like that, like that. As you keep going along, you will begin to form the bead. Now, the only problem with oxyacetylene welding rod, or oxyacetylene welding, is it's pretty slow. So, stick welding, or shielded metal arc welding, is a faster process that basically uses two terminals, and when those two terminals touch, it creates a 6,000-degree arc. Now, it all starts with a welding machine, and that machine, this right here is my engine-driven Lincoln electric arc welder that my great uncle gave me. So he didn't want it. Now the machine comes two leads. These are the leads. They're basically just wired. And on the end of one lead, there's a ground clamp, and at the end of the other lead is an electrode holder. The electrode holds the electrode. These are all different types of electrodes, and they get melted in. They're what melts. They're the rod, and that's what basically when those electrodes melt, they form the bead. So. Let's see. So on the outside of the electrode, there's flux. And the flux is what shields the molten pool of metal from the stuff in the atmosphere as it's cooling. The heat of the arc is determined by amps, and the more amps you have, the hotter the arc will be. If you don't have enough amps, you're not going to get very good penetration. And if you have too many amps, you're basically just going to burn through your workpiece. So that's a pretty quick summary of oxyacetylene welding and shielded metal arc welding. So thank you for being very attentive.